In this video, we will try to connect the cost of living with the homogeneity of the demand function. And for that, we need to understand the concept of homogeneity, and also the demand function has to be considered. So the demand function that we are considering here is expected to be homogeneous of degree 0. Now let's see how it is possible. The functional form of a demand function is as it is. As you can see, this is the standard form of it, that is the on price and the price of some related good and the income among other variables or prices. So in the process of finding out the degree of homogeneity, we introduce a scalar, and that scalar is k, for example, the symbol throughout in this given demand function. And as you can see, the scalar has been introduced wherever there was a variable, that is px or py or I, that is income. We have introduced this k, that is the scalar. So when we do this, we check that if we factor it out, if we bring it out, it has a certain power. And what is that power? That power will determine the degree of homogeneity of a certain function. In this case, it is the demand function, and it can tell us about the real life phenomenon of the cost of living. In this example, let us see how. Here we are assuming that k is a positive number in order to keep the relationships unaffected via a neutral number, which is a positive number. Now this is x status, and it is a function of px and I, as we have just developed in our previous videos, that the demand function was developed and it looked like this. It is the demand function of good x, and it depends upon px, that is its own price, and the income. Now if we introduce the same thing which we did before in the functional form, now we are doing this in this certain equation of demand, and it is k. So k is being introduced this time in an equation instead of the standard form or the function. Now this equation has been introduced with k and with I, that is the variable, the other variable px. We have introduced k, which is definitely visible on the left hand side, which is the functional form. Now this will remain the same as it is, but when we introduce the k on the right hand side, it will be cancelled out. So we get back to the original form of the demand function, and this is why I can say that this post transformation demand function is actually the same demand function that we developed before, where we did not introduce any k scalar. But how can we make sense of this finding that we did with in the light of this experiment? It is simply by judging the power of k. Since k is cancelled out, it means that k had power 1 here and power 1 here, so the value of the power will be 1 minus 1. It means that the power of k after this transformation will be 0. In other words, it will be equal to 1 whole of this boxed term, and when 1 gets multiplied with this term, it remains unaffected, that is this term will be the same. So writing k raised to the power 0 doesn't affect the result, and it remains the same that we have just found in the last step. So it means we can write k power 0. It means that the degree of homogeneity of this function is 0, which is dependent upon the power of the extracted scalar. We have extracted this k. We could also take it as a common factor and then cancel out. So once if it is factored out totally, that is, we cannot see k in this expression anymore, its power will judge the degree of homogeneity. So mathematically speaking, its degree of homogeneity is equal to 0, and we can write it equal to the original functional form of it. This is why these two terms are basically representing the original function, original demand function, and this is the functional form after the transformation, that is the introduction of k. Now the economic side of this transformation is that if people income is raised by the same proportion as inflation, that is the income is increasing, that is I is increasing, and by inflation we mean that all of the prices, in this case we are considering one price right now, so if there are more than one prices, they will also increase in the same proportion. And if this happens, then there will be no change in their cost of living, because the proportion is the same, the proportion in which the income is increasing and the prices are increasing. So they will nullify each other and there will be no effect on the cost of living. It is just like that they will remain at the same point of consumption even if the income has increased as well as the prices have also been increased. Let us see that if we increase the prices and income by a certain proportion, that is by it becomes 5 times of what it was before, the income as well as the prices. So diagrammatically it will have a certain situation that we can see here in this brief diagram. It's the same budget line that we have seen many times, and this is the point of equilibrium where the critical value of x1 and y1 they are appearing. Here we have calculated the slope. The standard form of the formula is minus px and divided by py, and here what we can see is that we have introduced 5 because prices have become 5 times, both of x and y good, and generally speaking it is k, so I can write k as well, but in both of the cases these will be cancelled out and it will revert back to the original formula. So the slope, the answer, the formula, it remains the same, and the budget line will remain where it was, and the equilibrium will also remain unaffected, and the consumption points will also be the same. We must not worry about these 3 values or this value, because these are the intercepts that we have been finding before. So in this way we can see that the equilibrium has remained unchanged, the consumption has also remained unchanged. In other words, what we mean is the cost of living has remained the same, it has not changed. So this is something we said, and diagrammatically as well as mathematically it has been proven, and it is basically due to the structure of the budget line. And here it is, the structure of the budget line is in front of you. You can see the prices, they are on the left hand side, and when we make them 5 times or 5 multiplied by 5, it also happens on the right hand side, because income is also now 5 times before. Now if we take 5 common on the left hand side, it will be cancelled out with this 5 on the right hand side. So this cancellation will keep the budget line the same, it will revert back to the original functional form that it has. So it means that the budget line is basically explaining this constancy of the cost of living of the individuals on the basis of this demand function, which is homogeneous of degree 0. This is how we can link the concept of cost of living diagrammatically and mathematically to make it a more concrete concept. Thank you.